So all we're doing with this, because they want us to find the word perimeter, and the perimeter just means to add everything up all around. So you just have to be careful. It can be a little misleading if you see those, because both of those 18 the square root of 18 are the same. And if you just did this and typed that answer in and turned that into 3 square root of 18 plus 2 square root of 32, you're not going to get the right answer. And while you can add those twos that I have underlined in red together, it's not enough, because what you now have to do is simplify this. And to simplify, remember, what you're looking for are these perfect square roots. The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, so on and so forth. And you only want to look to see which of the numbers that are underneath those radicals can divide evenly into either 18 and 32. So when I go ahead and do that, I can rewrite that 18 as 2, oops, wrong button. Come on. As 2 square root of 2 plus 3, and 18 becomes 2 times 9. And I do the same thing with 32. Now you just have to be very careful. So if you go ahead and divide 32 by 4, you get 8. And while that would work, it's not enough. So my hint to you guys is, if it ever is divisible by 4, always check to see if it is also divisible by 16, because you want to get the highest possible perfect square inside there. And 32 does divide evenly by 16, and that gives you 2 times 16. Now I take out the perfect squares. The square root of 9 is 3, so I multiply it times 3. The square root of 16 is 4, so I multiply that 4 times 2. Then I'm left with 2 square root of 2 plus 9 square root of 2 plus 8 square root of 2. Now all you do is you add the coefficients on the outside, because all of the radicals are the same. And 2 plus 9 plus 8 gives us 19 square root of 2. And that would be plus x quantity squared. It's really, really important that you focus on that quantity squared piece, because what that squared means when it's outside the radical like this, you must write this twice, then FOIL. So I have to write that as the square root of 3 plus x and the square root of 3 plus x. Now, remember the rules when you're multiplying. If something is outside the radical, you can only multiply it times what's outside. And if something is inside the radical, you can only multiply it by what's inside. So when I go to multiply the square root of 3 times the square root of 3, that gives me the square root of 9. That's because both of the 3's are inside the radical. The next one, when I do square root of 3 times x, that's just plus x square root of 3. I do the same thing with the next one, and that's plus x square root of 3. And then the last one, that's just your normal x times x, which is x squared. Now, I can go ahead and simplify this. I know that the square root of 9 is 3. And this is actually kind of, and I know this causes trouble when I'm adding these two together. So when you're looking at this, remember it's the square root of 3 that's your like term, right? So when you're looking at this, all I'm doing is adding the outside together, which really means I'm just adding x plus x. That's understood to be 1x and 1x, so that is equal to 2x. And this kind of really makes you focus on what you already have learned about combining terms. So be very careful with this. So this just gives me 3 plus 2x square root of 3 plus x squared. Now that would be your final answer. Now that is not written in descending order. If you want to write it in descending order, that also would be fine.